This morning we're going to talk about the actual beginning of wood turning. We're going to take a cylinder or a blank, and the first thing we have to do to it is actually find the center of each end. There's several ways that you can do that. You can take just a straight edge and lay it from corner to corner and mark an X. And that will find the center if you start with a perfect square. But if your piece is not perfectly square, then just marking corners will not find the exact center. The best way to do it is to use a center finder. It has a molded plastic 90-degree angle and a straight edge. You simply put the molded 90-degree angle into a corner and make a mark. Go to the next corner and make a mark. Go to the third corner and the fourth corner. So you mark all four corners. Now, this piece is square, so you can see in here that it looks like a single X, even though it's two. If this were not perfectly square, these lines would not be aligned. And then what you would do to find the exact center of one that's not square is to take a center punch and put it in the center of all four lines. This one would work as an example of that. I don't believe this one is square. Now, you can see on here that we have four distinct lines because this piece is not perfectly square. Now, to find the center of that, we would put the center punch in the approximate center of all four lines. Now, we'll mark the other side of this one because this is one we'll actually be turning. Now, this one was off just a little bit. You can see that they're distinct lines. So you would take the center punch and put it in the center, and we get a mark. We'll do the same thing on this side, and we get a mark right in the center. Now, since we're turning between centers, we will have to use a spur drive and a live center that we'll put on the lathe. These two parts will actually be used to suspend the blank between the two of them. The first thing we need to do, though, is to drive the drive center into the piece of wood. We'll use a mallet for that. There's a pin in the center of that. You would take that pin and put that in the hole that you made with the center punch, and then you simply drive the drive center into the piece of wood. You would take your live center, and that will go in your tailstock. So we'll put the And we put the pin in the live center into the depression that we made with the tailstock, and we just tighten it up. And it will be hard to see, but the live center is turning with the piece of wood. It's on a bearing. So now you're actually ready to turn. And this is how you find the center of a spindle and how you actually mount it on the lathe. In the next session, we'll show how to actually turn this blank round. Okay, and now we're going to take the blank that in the last session, we found the center and mounted it on the lathe. On this one, we're actually going to take the blank and turn it into a cylinder. Once you have it mounted on the lathe, the thing you need to be sure of is that it's going to actually stay. We're dealing with wood. As this actually compresses into the wood, your blank can get loose. So you need to make sure that you keep it tight. You can use the locking lever to lock down the quill so it can't move. But if it actually gets loose in between here, there are times when you actually need to loosen your locking lever and tighten it up a little bit more. The way I find out whether I need to is I'll take it and just shake it. If it doesn't feel solid, then I need to tighten it up a little bit. And then you can lock the locking lever. Now, the position of the tool rest is very important. It needs to be set up where it's actually parallel to the center line of the lathe. Now, I can't see a center line, but I can see the hole in the bed. So what I do is I just line my tool rest up with the way on the bed, and that gets me parallel because that line is parallel to the center line, and I can see that line. The second thing you need to do is make sure that your tool rest is going to clear everything. The only way that you can be sure of that is to actually rotate the blank by hand. If you happen to move this up a little bit too close, and then you rotate it, now move it up a little bit closer, and now you'll see that the wood is hitting the tool rest. Now that is especially bad if you find out it's going to hit your tool rest when you turn the machine on. That's why you always rotate it by hand. So that you know you're clear of the tool rest before you turn the machine on. Now, the height of the tool rest is also very important. You want the cutting portion of the tool. When you put your tool on the tool rest, you want the portion of the tool that's going to be doing the cutting on the center line of the lathe. So that will always put the tool rest below center. One of the biggest mistakes that students make in the beginning is they put their tool rest too high, and that causes all kinds of problems when you actually put the tool against the wood. You need the cutting part of the tool in the center. Now, this one is a little bit low, so I'll raise this tool rest up a little bit, and now this should put the cutting portion of my tool in the center. Now, because your tools are not all the same size, when you change tools, you have to change the height of the tool rest. So almost every time you change tools, you're going to have to readjust your tool rest. Now, we're going to actually start cutting, You'll notice I'm putting on my safety glasses. You would never ever turn on a lathe without at least safety glasses. So we're ready to turn the lathe on. We want to set the RPM at about 1200, and it's set pretty close to 1200. It doesn't have to be exact. You'll probably never get it exact. Now, the position of the tool is critically important. You want the flute of this roughing gouge at about a 45-degree angle, and you're not going to go straight in, perpendicular to the work. It's going to be back here at an angle because you're going to ride the bevel. You will hear ride the bevel 1,000 times this semester. You want to be on the bevel. Now, you can start at one end. And because the tool rest is long enough, I can get the entire blank. Now, as you can see, I'm taking off about the same amount of material on each pass. Now, the way that I'm able to do that is the position of my index finger. Every tool rest has what they call a finger groove. It's designed to put your index finger against. The tool goes down on top of the tool rest, but it's my index finger that controls the depth of the cut. If I want to cut deeper, then I slide the tool up a little further. But it's that index finger that actually determines that depth of cut. Now, another thing that you need to know is how you move your body. Now, when you're holding the tool and you're on the tool rest, if you just rotate from the waist, that's not the way to do it. Notice the cutting edge on that tool. What is it doing? It's going in an arc. Now, if you're at the lathe and you're just rotating from the waist, then as you come along, it will take you off the wood because you're swinging an arc. Now, the correct way to do it would be to shift your weight. Now, this moves the tool, but it moves it in a straight line because I'm shifting my weight from one foot to the other. Now, when you do that while you're turning, you go all the way across. The tool stays in contact with the wood, and you're able to maintain an even cut. Now, we're still not round, but you'll notice that the size of the groove is pretty much the same all the way across. Now, I'm going to go ahead and finish this and get it almost round. And then we'll come back and I'll show you the next step. Okay, now we've got it mostly round. You can notice there's still just a little bit of a flat spot, and we want that completely off. But we only have just a couple of more passes, and we will have our blank completely round. Now, you notice there's a much bigger gap between my tool rest and the work now because we've turned off some material. So as you do that, you need to readjust the tool rest to get it closer to the work. And now it's easier to see that the cutting portion is pretty close to the center. We're going to move it up just a little bit. And we're almost exactly in the center of the work, but yet my tool rest is below center. Your tool rest will always be below center because the tool takes up more space on top. Now, let me make a couple of passes and we'll get this flat spot off. Now, the top is not completely smooth. That's one of the reasons they call this a roughing gouge. It's very difficult to get a very smooth finish with a roughing gouge. But we want the top of this center to be very smooth. So we will change tools and we will move to the skew. Now the skew has a very, very sharp point. It's double beveled. There's a bevel on both sides. Now, the important thing about using a skew is you never want this long point or the short point to actually dig in to the wood. If that happens, you wind up with a very spectacular catch. We could do it with the tool rest here, but it's very difficult to do it and it's hard to see. So it's easier to raise the tool rest up quite high. And again, we want it parallel to the center line. Now we can put the tool up close to the top of the blank. And it's easier to see what you're doing. Now we want to make sure that the portion of the tool that's doing the cutting is close to the center of the skew. We want to stay away from that long point. We want to lay it down carefully, and we want to ride the bevel. So if I get right on that bevel, I can slide the tool across the wood and it will not cut. But if I raise the handle just a little bit, you can see it actually start to cut. So I will start at one end. I want to keep that cutting edge right in the center. And you notice my index finger is still doing exactly what it's always been doing. The depth of cut is determined by that index finger. Now, that did a lot to get this a lot smoother. But there were still some low spots. And if you run your hand across it, you can feel them. So I'm going to make one more pass and try to clean up. What I'm looking for is a consistent diameter from one end to the other and have it nice and smooth. And I'm just going to make one more pass. But you see, the actual part of the tool that's doing the cutting is in the center. That long point is well above the wood and it's not in danger of digging in. And now we have a cylinder that is very smooth and very consistent in diameter. And that's how you would use the skew to smooth the cylinder. And now we have the cylinder that we wanted to turn. In the next segment, we'll cover how to take this same cylinder and mark it and turn beads and coves in it. Now, in this segment, we're going to actually turn something specific on the cylinder that we made in the last segment. We're going to turn beads and coves on this cylinder. Now, when it comes to what you can do to a cylinder, there are really only three things that you can do. You can turn a cylinder, you can turn a convex bead, or you can turn a concave cove. But that's really all you can do. Everything that you do on any cylinder that's ever been turned is some variation on a cylinder, a bead, or a cove. So if you can learn how to turn good beads and coves, it puts you way ahead of the game in turning any other shape that you want. That's why we put so much emphasis in this class on turning beads and coves. Because if you can turn good beads and coves, you can turn anything on a spindle. Now, to lay out for the beads that we'll be turning in here, we need to stay away from the actual ends because we've driven this into here and we have a hole in this end. So a certain part of the material on the end is not really usable. So we will just make a mark at about 3/4 of an inch. Now, to take your mark and get it to where you can see it, when you turn the lathe on, you really can't see that little mark. So it doesn't do any good just to make the mark. We need to transfer that mark all the way around. Now to do that, we put a pencil against the tool rest, put it right on our mark, and as we rotate it, the line goes all the way around. Now when we turn the lathe on, we can see the mark. So this is going to be the beginning. All of the material on the left side of this is just going to be waste. So if we look at the book, and all of this coincides with the book, you have the documents all over or on the site in Canvas where you can actually read all of the written material that goes along with the videos. It's not like your English class where you don't need to read the book because you rented the video. You need to actually read the book and watch the videos to get the most out of the class. So we've got our starting point, and if you look at the book over here, it will show you all the dimensions that you need and how to lay out the first bead. Now we'll go back to our work, and we will make a mark at 3/16 of an inch, and then we'll make another mark at 3/4 and another mark at 3/16. Now we'll do the same thing with those marks. We can continue them all the way around the piece so we'll be able to see now. What we want to do now is actually cut into this at these 2 points. We're going to reduce the diameter at those 2 points by about 3/8 of an inch. We want 3/8 of an inch in depth. So we'll turn the machine on. We'll use the parting tool, and again you put it against the tool rest first. And we want to go down to about 3/8 of an inch in both places. Now, to find out whether or not we're actually close enough to that 3/8, we'll use a digital caliper. These are incredibly useful tools for a wood turner. This particular one can be purchased at Harbor Freight for about $30. Now, 2 or 3 times a year, Harbor Freight puts this tool on sale for about $10, and that's the time to get it. They sell one for $10 all year round, but instead of being stainless steel, it's plastic, and it's not nearly as accurate, or it doesn't have the lifespan. Now, at the other end, you'll see there's a protrusion that comes out, and that measures your depth. So if I wanted to know how deep this was, I would simply put that in there, move it down, and then I can look at the gauge, and I can see that I'm at 15/64. So that's about 1/4 of an inch. So I need to go a little bit deeper. This one is about the same. So I'm going to go just a little bit deeper to get to my 3/8. We'll put the parting tool back in. And that's pretty close, and they're about the same. So, rather than measure that again, I'm going to go ahead and go with that. So the center section is where the bead is going to be. Now, since it needs to be symmetrical, it would be really useful if we had a center line. So, we will measure the width of this, and we'll do the same thing that we've done with the other marks. So we now have a center line. Now, when I turn a bead, I like to leave this pencil line. If I take the pencil line off when I'm turning, I lose my reference. So I like to completely finish the bead with the pencil mark in place and then take it off when I sand. So to turn the bead, the first thing we need to do is to get a little relief on the side. So I'm going to put a mark about 1/8 of an inch on either side. And we'll now, by taking that down, I can just take my parting tool and come in here on the line at an angle. And it will do the same thing on this side. So now I just have a little relief. So when I start turning the bead, I'm not going to hit the sides with the tool, which can cause a catch. Now, the actual positioning of the tool, we're going to use the spindle gouge to roll this bead. Normally, I take 3 passes to do a bead. And I'm not going to start in the center. I'm going to start over here a little bit. So I'm not going to go all the way to the line, and I'm not going all the way to the bottom on the first pass. So if I start at the center and not make a complete pass, it's going to be much more difficult for me to keep this symmetrical. Now, the motion is a little bit difficult to get used to. You have to do 3 things simultaneously and in a coordinated manner. The motion, we're going to start with the flute open, and we're going to start with the bevel on the work. You can see I'm pushing the bevel against there and it's not cutting. Now if I raise the handle, now it will start cutting. So that's my angle. So I'm going to start with the flute completely open. I'm going to close the flute and swing the handle to keep the bevel on the work as I go. So it's going to look something like this. I'm swinging the handle around. Now notice the bevel on the wood. So it's still in contact with the wood. But I have to swing the handle in order to keep the bevel engaged on the wood. So we'll look at that again. I'm closing the flute and I'm swinging the handle. Now, as you look, you can see that's pretty close to a quarter circle. Now I'm going to try to do exactly the same thing on the other side. It's done the same way. I start with the flute open. I'm not going to start in the center. And as I close the flute, I will swing the handle. Now, if you look at that, it's pretty close to a hemisphere. It's done, it's all in tool position. If you use the tool in the correct way, and if you will use a coordinated approach, you have to close our cove laid out. We've got an 1/8 of an inch line, a 3/8, a 3/8, and an 1/8. This line would be the center line of our cove. The first step is to cut another diameter with our parting tool, similar to the way that we did on here in the beginning, to establish the depth that we want to go to. So we'll turn the machine on. We're going to use the parting tool, and we're going to center the parting tool on our line. And we're going to go to that 3/8 depth the same way we did before. Now that's close enough. So we now have a definite bottom to our cove. So we're going to go back and get our spindle gouge. Now we're going to work down from each side. When you're using a gouge in this fashion, you always go downhill. You never try to go uphill with a gouge. I'll show you that in just a moment. Now, turning of the cove is opposite from the bead. With the cove, we're going to start with the flute closed. And then as we go to the bottom, we're going to open the flute and again swing the handle. But it's going to be swinging in the opposite direction. So we're going to start all the way over here. We want the bevel to be perpendicular to the wood. If we don't, it will run. So we're starting with the flute closed. And as we engage that, you see the handle swinging across. And we end with the flute open. Now we'll go on this side and do it just the opposite. We're going to open, the flute is going to be completely closed. The handle starts over here, so we're perpendicular to the work. And then as we begin to swing the handle, we will open the flute. Now, you saw that little run. That's what it will do if you get off perpendicular. If you start with that perpendicular, it won't do that little running thing. But you end with the flute open and back perpendicular to the tool rest. So you start way over here and you'll end up here. Now we'll come back over here and do the other side. We'll take a little bit bigger bite, but we want to be perpendicular. And as we go, we swing the handle and open the flute. Now you'll notice up here that we're starting to get a curve. We want that curve to work its way down to where when we reach the line, we're at the bottom. But you can definitely see the curve that we're trying to establish. I'm not quite to the bottom, and I'm not quite to the line. So I'm going to make one more pass. And now we've got a curve. Now I'm going to come over on this side and catch up. I want to be perpendicular with that double, with that flute closed. Now, we've got curves on both sides, but it's not quite symmetrical yet, and I'm not quite all the way to the bottom. So I'm going to use the wood that I have left to make this nice and smooth. Now, I can show you now what I mean about going downhill. If you notice, when I make this cut, I stop when I get to the center because I don't want to try to go uphill. To get on this side, I need to come over here and go downhill on this side. And that's pretty much what we're looking for. Now, if it's not perfectly symmetrical, you can correct a lot of it with sandpaper and your finger. But that's close enough with the tool. The rest of it can be cleaned up with sandpaper. But that's how you would turn a bead and a cove. And if you were in class and actually turning this, you would just continue down the spindle, turning beads and coves, beads and coves, beads and coves, till you get to the end. Yours may not look like this when you start, but by the time you get to your third spindle, they would be very good. Normally students, by the time they get to the third cylinder, they're turning reasonably good beads and coves. So that's how it's done. You would just take what was shown on the video and continue on through. And that's how you turn beads and coves. Flute and swing the handle as you go around. And then that's your bead. You would put some sandpaper on here and you would be able to take off the pencil mark and smooth everything out. But that's essentially how you turn a bead with a spindle gouge. Now, there's a lot of people that turn beads with a skew. There's no shortage of professional turners that will tell you that the skew is the only tool to use to turn a bead. We just saw that's not altogether true. The reason I teach it with the spindle gouge instead of the skew is because it's much easier to learn. The skew, remember, is the most difficult tool in the box to use. It will turn a really nice bead, but the learning curve on turning beads with a skew is much higher than turning beads with the spindle gouge. And that's why I teach it in the beginning class. Now, we will go ahead and take this portion and lay that out for a cove. It'll be very similar to this. Some of the dimensions will be a little different. But I'm going to go ahead and get it laid out, and then we'll come back and I'll show you how to turn a cove. Our cove laid out. We've got an 1/8 of an inch line, a 3/8, a 3/8, and an 1/8. This line would be the center line of our cove. The first step is to cut another diameter with our parting tool, similar to the way that we did on here in the beginning, to establish the depth that we want to go to. So we'll turn the machine on. We're going to use the parting tool, and we're going to center the parting tool on our line. And we're going to go to that 3/8 depth the same way we did before. Now that's close enough. So we now have a definite bottom to our cove. So we're going to go back and get our spindle gouge. Now we're going to work down from each side. When you're using a gouge in this fashion, you always go downhill. You never try to go uphill with a gouge. I'll show you that in just a moment. Now, turning of the cove is opposite from the bead. With the cove, we're going to start with the flute closed. And then as we go to the bottom, we're going to open the flute and again swing the handle. But it's going to be swinging in the opposite direction. So we're going to start all the way over here. We want the bevel to be perpendicular to the wood. If we don't, it will run. So we're starting with the flute closed. And as we engage that, you see the handle swinging across. And we end with the flute open. Now we'll go on this side and do it just the opposite. We're going to open, the flute is going to be completely closed. The handle starts over here, so we're perpendicular to the work. And then as we begin to swing the handle, we will open the flute. Now, you saw that little run. That's what it will do if you get off perpendicular. If you start with that perpendicular, it won't do that little running thing. But you end with the flute open and back perpendicular to the tool rest. So you start way over here and you'll end up here. Now we'll come back over here and do the other side. We'll take a little bit bigger bite, but we want to be perpendicular. And as we go, we swing the handle and open the flute. Now you'll notice up here that we're starting to get a curve. We want that curve to work its way down to where when we reach the line, we're at the bottom. But you can definitely see the curve that we're trying to establish. I'm not quite to the bottom, and I'm not quite to the line. So I'm going to make one more pass. now we've got a curve. Now, I'm going to come over on this side and catch up. I want to be perpendicular with that bevel, with that flute closed. Now, we've got curves on both sides, but it's not quite symmetrical yet, and I'm not quite all the way to the bottom. So I'm going to use the wood that I have left to make this nice and smooth. Now, I can show you now what I mean about going downhill. If you notice, when I make this cut, I stop when I get to the center because I don't want to try to go uphill. To get on this side, I need to come over here and go downhill on this side. And that's pretty much what we're looking for. Now, if it's not perfectly symmetrical, you can correct a lot of it with sandpaper and your finger. But that's close enough with the tool. The rest of it can be cleaned up with sandpaper. But that's how you would turn a bead and a cove. And if you were in class and actually turning this, you would just continue down the spindle, turning beads and coves, beads and coves, beads and coves, till you get to the end. Yours may not look like this when you start, but by the time you get to your third spindle, they would be very good. Normally, students, by the time they get to the third cylinder, they're turning reasonably good beads and coves. So that's how it's done. You would just take what was shown on the video and continue on through. And that's how you turn beads and coves.